Hi students, today we will study function templates. So what is function template, how to define and how to use in a program. Function templates are a pattern for a function that can work with many data types. So it's a generic pattern uh, which can work with different data types like with integer, float, character, etc. Even with the user defined data types can also work. When we are writing the templates, the functions, the parameters are left are left for the data types, meaning to say we will specify general types and we will not specify the exactly the data types. But when the templates are called, the compiler generates the code for the specific data types. So the general data types is replaced by compiler when compiler call the function. It is something like this. The general syntax or the general template of a function is like this. That you see, first of all, this line is necessary. That you will use the word template and then the word class. This is not the class and objects. Okay, this word is just to show that you are going to define a template, and this is the general data type. You can use any variable here. Is t is used, but you can change this one with any character. So this line is necessary. You will write first at the beginning, and after that you will define a function template. And as we know that each function has a return type, so you see the return type is a general return type t. We don't mention that it is int or it is void or it is what type. Okay, so this is the function name. You can use any name that you want, but here times 10. Okay, and this one is the argument. Okay, the argument data type, it may be integer, it may be float, but now we are using generic. So you see, whatever data type, general data type you define here in the template, the class, this t will be used everywhere that you use the data type. Okay, and this is the actual coding, like the name of the function show times 10. So any argument will be multiplied by 10 and that will be returned. So this is the general template. Okay, but when this is called by the compiler with integer argument, okay, so meaning to say when we pass this value as a integer one, then the compiler generates the template like this. And note the point that this will be generated in memory. Okay, this function, you see, now each t is replaced by the int because we pass the value as a int. Okay, so compiler will generate a copy of the template during runtime in a memory, depending on the argument, what type of argument you send to the function. Okay, so all the generic values will be replaced uh, mm, by the value that you call with. And if let's suppose you call with a double value, then compiler will create the double version of this template. Okay, if you call with any other data type, compiler will generate the that version of the template. Okay, so it is something like this, you see. So this is a general template. The prefix must be used like this. Okay, the word class, this is a generic data type, and these are the parameters. Okay, and the return type and the arguments parameters. Okay, so you see the same thing, that if we when we call this function, Okay, it will be like this. For example, if we have integer value int the value 3, and if you call the times 10 function like this, okay, and you pass the value as a argument, so this value is integer value, so compiler will create the integer version of this template. Okay, now another one, if you call with a double value, you see here is a double value. So if you call the same function, the same template with a double value, then compiler will generate a double version of this template. So what does it tells us? That actually template is a general function. We don't specify the data types inside the function, so it's easy to call with any type of parameters. So no need to define so many functions. For example, if we are not using template and we are using normal functions, then we will have to define a function for integer, or function for double, function for float, function for long integer and short integer, and so many versions are possible. So all these can be used by one function template, just specifying the numeric, the general data types. So so it can save our time, it can save the space, no too much typing, and it is easy to type, and it can save us from different type of typos also, because when we are typing many things, so there is a possibility to make mistakes. So function template is merely a specification of a function, and by itself doesn't cause memory to be used. So the function template by itself doesn't occupy any memory, exactly like a classes. Classes doesn't occupy any memory. So in the same way, the function template doesn't occupy any memory. Okay, an actual instance of the function is created uh, in a memory when the compiler encounters a call to the template function. So it means that when we call the template, then then one w- uh, then one instance is created of that template in a memory. Okay, and it's a temporary version. When the function call complete and the execution complete, then the compiler will delete that version. This program show the use uh, of a template, a function template. So you see here we are using the line template class T. Okay, and after that we are using T square T number. So it means this is a function that when we send one number to this function as a argument, it will return a square of the number. Okay, but we just left all the data types general, the character T. You can use here any character. T is not compulsory, but whatever character you use here, like T here in this line, so the same T you will have to use here also. If you use here, let's suppose A, then the same A will be used here also and here also. Anywhere the data type is used, you will use the same character. So this is a general um, function template. So in int main, we create one variable, integer variable, and one double variable. Now we are getting the values from the user for the integer and for the double, and then we are displaying the square function with int one time and one time with double. So when we call with int, okay, the compiler will generate the int version of this template, and when we call with a double, then compiler will create a double version of this template. Let's see the output. Enter an integer and a floating point value. For example, integer 5 and floating point 5.5. Okay, so here is their square. So integer square and uh, floating point square. So you see the template is working properly. We just use we just define one time, and we can call with different type of arguments. So compiler will generate all these things. So it's easy, and it's a very professional way of defining functions. Okay, so templates can use multiple parameters also. For example, in this case, template class T1 and class T2. So you see, these are the parameters, the general parameters that we want to define. So the first line is compulsory that you will use template. Okay, and then for each parameter you will define a generic symbol or generic name. Okay, so this T1 and T2 are generic names for argument 1 and argument 2, and whenever the argument 1 is used you will have to use T1, and whenever the argument 2 is used you will have to use T2. Okay, for example, the function uh, uh, this one mpg, so time t1 and t2, so two arguments are passed to this template. So compiler will generate automatically uh, 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 any version of this depending on what type of value you have used when you are calling this template. Okay, characters. So here you see we define the function template. We use the generic type T, and here we are using two arguments the of type T, but here we are using reference variables of both. Here also reference variable and here also reference variable. So the purpose of this template is to swap the two arguments with each other. So for this purpose we are creating one generic variable, and you see the variable is also of the generic data type. Okay, then the temp equal to variable 1, and then the variable here is the swapping. So the variable 1 value is replaced by value 2, and the variable 2 value is replaced by the temp 1. So the two variables swap their values with each other. Okay, so here you see we are creating two variables of type character, first character and second character, and again integer, two integer and two doubles. So when we call this function, enter first two characters, so then we will enter the two characters, and we are calling the function with character arguments. So it will display, it will swap the values, and compiler will generate the character version of this template. And after the two integers, and when we call with integer arguments, the compiler will generate integer version of this template. Similarly, with floats, when we call this template with float or double, compiler will generate the double version of this. So if we enter two character, for example a space z, so if I enter this one, so you see the first I enter a and then enter z, but the z is swapped by a, and the a is swapped by z. So you see the order is changed now. They are already swapped. Now two integers, for example, first one is 10 and second one is 100. So you see again swap 100 first and 10 after that. Then floating point like 5.5. Next, uh, all the data types specified in the template prefix, like the template class T, that is the prefix, okay, must be used in the template definition. For example, it means that if you have used T, then the T must be used in the coding also. And function call must pass parameters of all the data types specified in the template prefix. So when you are calling, for example, if you have used T one time, then when you are calling them, you will pass one argument. If it is multi-parameter, okay, so you will pass multi-argument. Like regular function template must be defined before being called. So it is the same like normal functions, that when you are calling the template must be defined before. Otherwise, compiler don't understand what we are calling. So you see the template is defined before int main. So when we are calling in the int main, then compiler know what swap variable is. So compiler already come through this coding during the compilation process. Okay, so all functions template is a pattern. It is just a pattern, not this keyword. It is just a pattern. Okay, so it means it doesn't occupy any memory. It is just a pattern, and it will be replaced by the compiler. No actual code is generated until the function name in the template is called. So meaning to say, no code will be generated, no memory will be occupied until the compiler, until there is a real call to this function. And a function template uses no memory. You see, it is just a pattern, it doesn't use any memory. When passing a class object to a function template, ensure that all operators in the templates are defined and overloaded in the class definition. It means that in these examples, we have used built-in data types, like here. You see, we have used built-in data types character, int, and double. So for compiler, it is not a problem. Compiler already know how to deal with character, how to deal with int and double. But if let's suppose you are using here classes or objects, okay, then for example object plus, okay, how to apply plus operation on object, how to apply minus operation on object. So then you must have these operator overloaded in the class. The one professional tip that where to start when defining a template. So actually the best way that when you are defining a template, then it is a good practice that first you define the function. Okay, First, first you define the function, what you want to do with that function. Once you complete the function and you test it, then convert the function to template. It is the best way. Meaning to say, start from function and then convert to template. Not like this, that start from template and then call that template and use it as a function.